Hello everyone, I hope all of you are doing well. So today we are going to solve two interesting problems, number 100 and 101. The problems are called same tree and symmetric tree. So they both are based on same concept. That's why I have taken these two together. And without further ado, let's dive into the problem. So the problem says we have been given the roots of two binary trees P and Q, and they want us to write a function to check if they are same or not. So the given examples are like this. So we have been given two tree P. So the P tree is 1, 2 and 3, and similarly we have another binary tree 1, 2 and 3, and they want us to tell whether these two are similar or not. And the two binary trees are considered same if they are structurally identical, meaning the nodes have same values. So what we'll do is we'll compare the subtree of P with the subtrees of Q. And if we found that the left subtree of P is similar to left subtree of Q, and the left subtree of P is similar to left subtree of Q, then we can immediately say that both these trees P and Q are identical, and hence they are same and will return true in that case. Otherwise, we will return false. So that would be the logic to solve this problem. And now let's dive into the writing the code for this problem. So like we discussed, first we need to compare the left subtree with the right subtree of the left subtree of P with the left subtree of Q, and right subtree of Q P with left subtree of Q. So for that we are going to call the functions recursively. So that's what I'm writing. So we'll compare P dot left and Q dot left, and we need also P dot right and Q dot right. So we need the right subtrees to compare as well. So that is the simple writing thing. So now once we go deep into our subtrees, the condition for checking that the two subtrees are same or not. So if the subtrees are null, so if P is null or my Q subtree is null, then we'll return false, or the values of P node and Q node do not matches at any point in the respective trees, then we'll return false. Otherwise, we'll return true. So if the P node or tree at any point they are similar, then we'll return true. So this would be the case once we have reached recursively to the bottom of the lead node and the values are same and the nodes are same. So here we are comparing the whole node instead of just the values. So that is the approach for solving this problem, and let's run our solution and see how it performs for all the test cases. So it has been accepted and it's running pretty fast. So this is the basic way for solving this problem, but I want to make this problem reusable and the code reusable. So I'm going to write it in a little advanced way so that this code becomes reusable. So what we'll do is we'll just take out these conditions the way it is, and we'll add it to our recursive conditions only here. So here we want to compare that if the trees are null, then why don't we compare the trees as it is and return the values based on the trees P and Q. If they are equal, then we will return true. If they are not, then we will return false. And values will just compare over here, that if that value P value is not equals to the Q value, or if it is equals to Q value, then we'll return true and false based on that condition. So this would be the advanced way of writing the same code above, and let's submit this and see how it performs for all the test cases so that we can use this concept to extend into our next problem. So I hope this is clear to you, and the same concept will apply into this symmetric tree problem. And here the problem definition of symmetric tree is that we have been given the root of a binary tree and they want to check whether it's a mirror of itself. That is symmetry around center. So here we are comparing the nodes value like this. So here we are comparing the left subtree with the right subtree, and here we don't have two subtrees. Here we just have one tree which has two parts, or we have just one binary tree and they want us to compare, tell us that whether it's a symmetric tree or not. So what I'm going to do is I'm going to divide this symmetric tree into two portions. I'm going to make this subtree as P and make this subtree as Q, and I will compare the left subtree with the right subtree named Q, and if they are mirror images, meaning the left of P is equal to right of Q and the right of P is equals to left of Q, then we can say that this is symmetric, otherwise it is not. So I'm going to apply the same concept that we learned before, that we'll need just one same function. So we'll need one function. So we'll return that function as DFS and we'll split our main tree into two parts, left and right. So that would be left and right, root dot right. And so this function, what it is doing, basically it is passing into two subtrees into it. So this is the DFS function recursively which I am writing, and here I'm going to write the same code that if not P, if P is none or the Q is none, basically the tree is node is empty at any point, then we want to compare the two trees together and we'll return the values of these two trees based on the comparison. If they are symmetric or equal, then we'll say that it's true, otherwise we'll false, and we need to compare the two trees left and right simultaneously. So what we'll do is we'll check basically whether the left of P is equals to right of Q and the right of P subtree is equals to the left of Q subtree, and if it is, then we'll say that this tree is asymmetric, and also we need to compare the values as well. So based on value, we'll say additional condition that this conditions applied all of them together. So if the result for all of them are true, then we can say that this whole tree is symmetric, otherwise not. So let's submit our solution for all the test cases and see how it performs. So this has also been accepted. So this is what I wanted to show you, that the same concepts can be applied to different problems. So we should be writing the code or learning the code in a way that the code becomes extendable. So which is one of the principles in solid that we use, that our code should be extendable without changing the base cases or base libraries or base objects. So that is one of the principles of solid. So I hope you guys are liking my solution, and if you have any particular problem, please let me know and I will have a look. And till then, thank you, be safe, and I will see you tomorrow with new algorithmic problem to solve. Thank you.